Hello and welcome to another JFrog tutorial. The focus of this topic is the architecture of Artifactory and the benefits of checksum-based storage. The movement of files necessary in software development comes with a high cost of performance. Artifactory uses a strategic architecture that simplifies file storage and movement, which increases performance and saves space. In this tutorial, we'll take a look under the hood of Artifactory, how it makes use of checksum-based storage, and the benefits of this unique approach. Artifactory is a multi-layered system that enables interaction with users and machines on one end, and databases and repositories on the other. In the middle, we have a caching and virtual file system. Let's take a closer look at these layers. The top layer of Artifactory is the user interaction layer, which is over HTTP or HTTPS. Interactions with this layer might occur in three ways. The first interactive option is the Web UI, written in Angular JavaScript, and, as of version 5, is completely stateless. The second option is a WebDAV interface option. Within WebDAV, you can use an Artifactory repository as a storage mount point on your file system. The third option is a REST API interface. Most interactions with Artifactory will use the REST API because the typical user is not a human, but a machine. These three types of user interactions are important consideration for Artifactory administrators. Deciding how Artifactory will function in a fully automated world plays an important role when you design your development lifecycle. Below the user interaction layer is an optional caching layer. Using a cache can accelerate very large repositories, reducing the load of back-end network and storage. The cache executes on local disk before writing to NFS. Below the caching layer is a virtual file system. This is the magic of Artifactory. The virtual file system contains checksum-based file storage that virtually accesses the file store, while all logical metadata is stored in the database. We'll explain the magic of this system in a moment. The last layer of Artifactory is the layer that connects the database and the outside world. Artifactory ships with Derby database, which you can replace with any standard SQL database. Some of the common options are MySQL, MariaDB, Oracle, Microsoft SQL Server, or PostgreSQL. Artifactory fully supports these databases with the relational JDBC connector, and continually test them for both performance and functionality. DBAs should select a database of their preference, because a happy DBA is a happy database. Besides connecting to the database on this layer, Artifactory has an HTTP connector to the external world. This is how Artifactory accesses remote repositories. It is also a two-way connection with JFrog Bintray that pulls data from JCenter and pushes it to Bintray via distribution repositories. Now that we've looked under the hood of Artifactory, let's return to the virtual file system layer and its checksum-based storage advantage. Artifactory's checksum-based storage provides a transactional, consistently healthy, corruption-protected storage layer. Because it's a one-time storage concept, checksum-based storage provides significant performance and disk space savings. Disk space savings of 15 to 30% are not uncommon. In this system, files themselves are not actually moved. What's moved when you copy and move a file is the database reference for the file. Since only the reference to the file is moved, transactions in Artifactory are significantly faster than traditional file systems. So how does the checksum-based storage work in Artifactory? Let's take a look. For each artifact stored in Artifactory, its checksum is calculated. The checksum SHA-1 calculation becomes the artifact's unique ID. Artifactory changes the file name to its checksum and stores the file folder labeled with the first two letters in the checksum. As the checksum is calculated in the file stored, a new record is created in the database with the repository name, local file path, and reference to the file ID. The artifact is only stored once. Any additional uploads with the same checksum will result in only a metadata update. No additional binary storage is used. Since move and copy operations are just lightweight database transactions, they are cheap to execute in terms of both performance and I/O. When you try to move a file from one location to another, Artifactory sends checksum headers. If the file already exists in the destination, it is not transferred even if it exists under a different path. Let's take a look at these checksum files in a live directory. Here we are in Artifactory's data directory. Inside the data directory is the file store directory. In the file store, we have a list of directories, all labeled with the first two characters of the SHA-1 checksum. When we open one of these directories, we find a file with the SHA-1 checksum base name beginning with the same two characters for which the folder is named. The metadata for this file is stored in the database and includes information about the repository, the file, and the path to the artifact's location. One important thing to remember is that the hashing algorithm for checksum calculation is used to generate unique checksum file identities. It is not being used for encryption purposes. Now that you know how Artifactory uses checksums to store artifacts, let's take a look at why this is so useful. Referencing artifacts by their checksum prevents duplication, since files are never stored more than once. Copy and move operations do not involve any file system activity. Instead, just the file references are added and removed. Expect significant file system performance gains since the system never actually copies or moves files. File system write locks are not required. Garbage collection handles file deletion. Default scans are run every 4 hours for this, but this setting can be customized. The system greatly improves search stability and performance, because searches operate on only the indexes in the relational DB. The strong bond between the artifact and the metadata can be extended to any sort of metadata. Since the metadata is stored in the relational database, almost any type of information can attach to the files in the database. For example, you can include data such as build number and name, commit number, properties, and test results. The Artifactory internal architecture provides a robust system for the artifact repository. At the heart of the internal architecture is the unique checksum-based storage system that removes the pain of duplication, saves space, and improves performance and stability. In this tutorial, we took a look under the hood of Artifactory, how it makes use of checksums to store artifacts, and the benefits of this unique approach. Remember to look for more information in our online user manual and other resources you can access from the JFrog website. Thanks for learning with the JFrog Academy.